Aloha! Welcome to Hawaii. I'd like to call it the world capital of the curvature because we can see the curvature very well thanks to the tall islands and a wide span of sea level surrounding them. So here's the island chain of Hawaii. We got the Big Island here. We got Maui. We got Oahu, the most populated one where Honolulu is. Here is Kauai and his little brother Ni'ihau, which is only populated by Hawaiian natives. Here's Molokai, Lanai, and Ka'olave are very visible next to Maui from our observation point on the Big Island of Hawaii. And today we're going to be observing the tiny little island of Molokini that sits right between Maui and Ka'olave. Let's go take a look at it. Little crescent-shaped island right here. And it's close to McKenna Beach on the Big Island, on Maui. And McKenna Beach has got two beaches. Just so you know, it's got Little Beach and Big Beach. Big Beach if you want to go swim with regular people. And if you want to take your clothes off, you go over the rocks here and you go to Little Beach. But today we're not going to observe any nudies from the Big Island. We're going to be observing the tiny little island here of Molokini. You can see that it's popular hangout. Nobody lives on Molokini, but a lot of people go there on a daily basis to go hang out with the fishies in the water. Okay, just take a little quick look at it. It's very flat as an island. Okay, and look here, how tall is Molokini? Molokini is only 160 feet above the water level, and 160 feet is the tallest point on the ridge because you see it kind of dips here in the middle, so it's not as tall as 160 feet. Okay, and we're observing that from the Big Island. And what we're going to do today is we're going to take a little hike. Well, I'm going to take the hike. You guys are going to sit comfortably at home, smoking your cigar, drinking your champagne, eating your caviar, or your McDonald's, whatever. Anyway, please stay healthy. It's going to be a bit of a long video. Sorry to tell you, but it's worth watching if you're interested in knowing what's going on in this world. So I started my first observation up here where I work, and I hiked all the way down between Mahukona Beach Park and Lapakahi State Historical Park. Okay, and you're going to see all those details in my video. But you can see here how it's green up there and how it's brown down there. Goes from very lush green down to desert. Let's take a little measurement of our elevation to begin with. Also going to bring my altimeter down my hike. Just to show you, because my altimeter, as you will see, sometimes it's not so accurate. Let's start from here. First point of observation, 1463 feet, according to this website. So let's bear that in mind. I was at 1463 feet. Okay? But what I want to do here is observe if we see curvature. Okay, so how can we calculate the curvature of the Earth? There are many websites how to calculate the Earth curvature, and they pretty much have all the same formula, which is you square the number of miles that are observed, and you multiply that by 2/3 of a foot to see what height you're not supposed to be seeing at that distance you have squared in miles. And you shouldn't be seeing anything below that height in feet. Okay, my favorite website to calculate the Earth curvature is this one here, because it has a little drawing. And a little drawing helps us understand that what we're dealing with here. If we have a ball Earth, okay? So if we have a ball Earth, according to Robert, who got asked by other people at all levels, Robert the expert here doesn't say where he got his number, but that's the number he starts off with. 3,963 miles, which is supposed to be the radius of the Earth. Okay? So he started off with this precise number. He didn't round it up to 4,000 miles or 3,900 miles. It's really 3,963 miles. Okay, if you don't know much about math this is the wrong video for you. But math is not that complicated. No. I used to be good in math, but to me, it's not that hard. It's still not that hard. Anyway. So, according to Robert the expert, using the Pythagoras triangle, a squared plus b squared equals c squared, he winded up with the value here of 7.98 inches after measuring 1 mile. Okay? Remember, you gotta square those miles. Squaring 1 equals 1. So he gets approximately 8 inches in 1 mile. Okay, which is 2/3 of a foot. Let's pull out the calculator, see what we can get. Okay, so you know the value of 2/3, right? Which is, I don't know if it's a really satanic number, but it's this number here, 0.6 periodical. All right, so 8 inches into a foot is the same value, right? Okay. Now let's use 7.98 inches into a foot. Divided by 12. So we got 0.665. So just a little bit smaller than 0.6 periodical. Okay? You got me here? So this formula here, it's supposed to show us this little height here. We're not supposed to be seeing anything taller than this little height we're going to wind up calculating here. Okay, as if we are on a globe, on a ball Earth that has this dimension here. Okay? So, let's see. Let's go back to our map, because we're not quite done here figuring out our bearings. I want to measure the distance between the two. Okay, so my hike is around like this here. Let's start from the top. Measure distance, please. To Molokini. So we got 52.25 miles. Okay, and now let's take a measurement from down on the coast. To Molokini. 49.64 miles. So we can like take a little average of 50 miles if we want. Okay, let's do that with the calculator. So we got 50 miles here. We square that number. What should it make? 2,500 makes a lot of sense to me. So we multiply that by just a little bit below the value of 2/3. So according to Robert and his theorem, we shouldn't be able to see anything below 1,662 feet. If I were to be standing on the shoreline of Molokini with my eyeball right along the water level and looking up towards where I was observing, I shouldn't be able to see any part of that mountain below 1,662 feet. Okay, bear that in mind, please. Now let's go look at my footage. All right, let's start the hike. So, standing on the hill, looking at Maui on the right here. Here is Kaolave on the foreground, and Lanai. Okay, and here is Molokini. Can you recognize Molokini? You can see the little dip in the island. Remember, the height is 160 feet tall. And if we look at it real carefully, we can almost see the shoreline. And if you see that shoreline, it's kind of whitish, it actually sits below the horizon line, which is the curvature point where it curves. So we're going to be hiking down this hill. Look how brown and dry it is down there compared to where I'm standing. See down here, the long building is around Mahukona. This one here too. This brown building, long. They used to fix boats in there. Big warehouse. And you can see a little boat here. And behind that hill is Lapakahi. So let's go down and observe. Next shot. I went down, jumped over the fence. So I pulled out my altimeter and it says 1,380 feet. Okay, am I seeing it well? Not sure with my camera eye, but let's take a look again. 1,380, you see that number? 1,380. Oh, 1,482. My golly Josh. 1,482, it was 1,380. What's wrong with this altimeter? Does any other scientist in this world use this altimeter? Oh, it went back to 1,380. 1,482. Whoa, what's going on? Am I going up and down in this world? 1,380 again. Well, let's stick to this number. It makes sense to me. We're still looking at those islands. Here is Lanai in front of us. And here's the barge floating on the water. Here is Molokini, our island that we're observing today. And look again, you see the shoreline, which is, see the shoreline, it's a bit, let me get it again. You kind of see the line, which is below the horizon line, where we see our curvature at this elevation. You see that difference? It's kind of not so clear, but it depends. All depends on your camera and your eye, on your phone or your eye or whatever screen you're watching it on. Okay. Next one. Hike down a little bit more. What do we got? 1,305. Okay, it makes sense because I hiked down about 100 feet or so. Here's Maui. And we'll still be observing. Here's Kaolave in the foreground, Lanai. And here's Molokini. Okay, again, you can kind of see the shoreline lower than the horizon. Okay, can you see that on both sides? Okay, you see it? Next shot. Oh, I didn't zoom out. There we go. 1193. Again towards Molokini. You can see the barge has moved in closer. The barge bringing us our goods. Okay, again, you can see the shoreline, kind of, below the curvature line. And remember, I wouldn't be able to see that below 1,662 feet. I wouldn't be able to see the shoreline. Okay? You're not convinced yet? Just keep on watching. Next shot. See the grass is growing a little bit more brown. Where am I? Again, 1197. I thought I went down like 100 feet or so. Anyway, let's keep on looking. What do we have? There's Maui. Oh yeah, let's take a little look here at Hana on the east end of Maui. That I'm actually in a nice space where I have a view of it. On that part of the hill, you can see little waves splashing on the shoreline. You can see little trees on the right side here. Okay. If you haven't seen my other video about where I saw the curvature for the first time, that's what I was observing from Hawi. Heading away, going towards Molokini. Oop. Let's look up on Maui. It's very summit, going down. See, it's McKenna. Oh, here is our little island of Molokini. You can see the barge is now transiting across in front of it. And can you see the shoreline? Does it still look below the horizon line? Can we say yes, yay or nay? Okay. There's McKenna. Too bad we can't see the nudies on Little Beach, but would it be really worth it? I mean, look at anybody nude. Does it really look like, wow, they're nude finally? No, it's not always worth it. Anyway, this video is not about nudity. It's about reality. So down below 1100 feet at 1075, 1075 feet of elevation that I'm standing on, and I'm observing towards, here we can see, whoa, we're looking at Lanai. You can see the barge again. It moved a little further past Molokini we have here in front of our eyes. Can we see the difference between the shoreline and our horizon, our curvature? It's getting a little bit harder to distinguish if there's any difference anymore. But I think I can still see some. My eye can see it. How about yours? All right. Next shot. Keep hiking down. Here I'm 970 feet. Always good to find a little bit of shade under a tree in the middle of the desert. It's not the desert quite yet. I'm still in the field. Sorry about the jump. Here's Lanai. You can see Lanai and Kaolave, but we want to look the other way. Lanai again. And where's our Molokini? Here it is, Molokini. Can you see? Alright, do you see it? Do we see the shoreline before the curvature line? We're just below 10,000 feet of elevation. And I can still kind of depict a tiny bit of a difference with my eye. The barge is a little further now. Still going down. 865 feet of elevation. According to my altimeter, my scientific instrument. By the way, I've done several videos about establishing the elevation, and there are many websites about elevation finding, and they're not showing all the same data. Oh, what do we have here? What do we have here? It looks like the horizon here is pretty much flattened out the shoreline of Molokini, and you can see the dip on the ridge here. Looks a little bit closer somehow to the waterline, water level. Can you see that? It almost looks the same. Pretty much looks like a straight line across. There's some Kiave. The missionaries brought Kiave, which is mesquite from California, Arizona. They brought that to the Hawaiian natives to keep them from walking around barefooted so they could buy shoes. Can you believe that? How the Jesuits treat people sometimes. It's insane. 787 feet of elevation. Okay, we're below 800 feet. We're below 800 feet. I'm observing Molokini. You can kind of see it here as we're zooming in closer. What's going on with Molokini? Sorry, I was having a hard time seeing it. My eyes in the sun. Sorry if I don't wear sunglasses, but I can't stand them. Okay. Please bear a little patience here. We're gonna see it. Sorry I didn't splice any parts of the video. I want to show you how true it is. If I just throw a bunch of pictures, somebody could say, "Oh no, you faked it. No, we don't believe you. You made it up." No, I'm a Leo, and Leos, whether you know it or not, they like to say the truth. Can't say the same for Bill Clinton, but most Leos were truthers. Sorry, this is Kaolave in front here, and here is Lanai, okay? And I was having a hard time seeing Molokini at this point. Why was I having trouble? You're gonna see why. You're gonna see what I'm talking about here. Thanks to your patience, mostly. Oh, here it is. Here it is. Okay, you see this? One hump and another hump. Don't tell me that's a cloud. Okay, so you see that the horizon line is starting to eclipse the island of Molokini. So you see the dip here on the ridge of Molokini. The ridge top is 160 feet tall, remember that. And we don't see, it kind of looks like it got cut in half at that elevation. And we're right below 800 feet of elevation. Okay, you see that well? One half of the island, the other half of the island. Let's pull our calculator back out again. So remember, our distance, like 50 miles or so. Okay, our calculator is... So we're not supposed to be seeing anything below that at 50 miles away. We're squaring that number, we get 2,500 times a little bit less than 2/3. So we're not supposed to see anything below 1,662 feet, according to Robert and his theory. Calculate the curvature of the Earth, because he started off with this precise number, but how come we get about half the value? Half the value of what we're talking about. You know, I'm standing here below 800 feet, and now I'm starting to cut off that island. Okay? But I'm not done with this video. Keep on watching. I will give you some orders here, but it's for your own benefit if you want to understand what kind of world we live in. If one day you want to put the bill up to the NASA guy's nose and say, can you guys please pay back those 60 million a day you guys been getting for all those years and decades? All over lies. You've been making up all these lies with CGI and camera tricks, you know, filming underwater in giant swimming pools, or going up in a plane, doing some loops in the air so you can look like you're floating around in a capsule. And when you're giving us interview where we can hear you talk, how come you guys are not floating around in your capsules? You're just standing there like soldiers, and you're pretending that you're bouncing around in your harness, hung up on some bungees. Every now and then we can see a hand fixing the harness while you're not floating around in your capsule. And how come the lady's hair is always so stiff? It looks like you could hit it with a baseball bat and crack it. Here we can see Molokini again, and I'm still at 700 and some feet, and I'm still cutting off the island in half, eclipsing this island with the curvature of the Earth. The curved Earth doesn't mean that we are on a ball. If we look at the sun, the moon, they look like a ball. Does it mean that we're standing on the same kind of object? I don't think so. There we go, Molokini cut in half. So we haven't hidden the top yet of 160 feet tall. And we're standing at 700 and some feet of elevation. Here is Maui, Makena, big beach, little beach somewhere in front, and that's La Perouse Bay here, the shoreline of La Perouse. Okay, I don't waste too much time here, but we saw it. We saw Molokini split in half. Here we go again. There it is, one half, and the other half, as we're zooming out to keep hiking down the hill. Now, 721 feet elevation. I didn't go down very far because we're in a crucial moment here as we are eclipsing the island of Molokini. Look at Maui, you can see the clouds starting to fill in the Haleakala crater, the largest crater in the world. The morning condensation starting to build up in there. Nice place to hike if you want to go visit Maui. You can actually hike all the way down the bottom of the crater. But you got to start at the summit, and you got to get back to the summit before you leave. Here's Makena again. Starting with Makena, it's easy to go left, turn left, and find Molokini if we can still see it. Because remember, we're in the middle of eclipsing that 160 feet tall island 50 miles away. It's the end of La Perouse Bay. I'm gonna need to be a little bit patient. Oh, there it is. Thanks for your patience. You can see a little tip sticking out, and not much on this side, but since I was still looking for it, we're gonna have a hard time seeing it again. So see, it's right there. Ding. One tip sticking out, the other tip sticking out. You see it? You gotta be real good. Then I went away. Nope, I'm still seeing it. One point sticking out, the other part of the island here. So we're getting close to our summit of 160 feet here. Okay, panning out, panning in. Here it is again. One tip, a second tip of the tiny little island of Molokini. It is an itsy bitsy teeny weeny little island called Molokini that I'm not gonna quit my day job over. Alright, you saw it. Let's skip to the next one. So at 721 feet, I can still see the very top of Molokini. Here, glad to be in the shade. Whereas the sunlight can show you that number, 646 feet. Not a bit of sunlight between the tree branches, 646, okay. And looking at Maui, you can see more clouds filling in the Haleakala crater. You can see the little observatory up there at the summit of Maui that's observing what? Space? What is space? I thought we had a firmament up above us, according to the scriptures, that separates the waters from above from the waters of below. But a whole lot of money goes up in space. A whole lot of taxpayers' hard-earned money goes up in space. Should we be paying all this money for wasted space that nobody, not even your grandchildren or great-grandchildren, are ever going to go to? for the promise of the future of mankind. Come on, wasting all that money where nowhere is gonna go, or if they ever do, it's gonna be who? The top most luckiest person in the world that's gonna be following an illusion? So sorry, I'm looking at La Perouse Bay here, and I'm trying to find Molokini in vain, because at this point, we've gone too low on the mountain slope. We're below 700 feet. So if we're looking out the horizon, the curvature of the Earth has eclipsed, has hidden Molokini completely. We can even see the top, 160 feet tall. We might see it if we're very lucky, just the very top. But why bother? It would make too many people argue. No, you didn't see it, man. It's just a little cloud. There's somebody out on the boat. Anyway, please keep on watching. Just got other features to show you. 570 feet of elevation. We can see more clouds filling in Maui, the Haleakala crater. And you can see here those guys. You see 1, 2, 3, 4, 5, 6, 7, 8 soldiers, 8 windmills standing on the slopes on Maui. And I'm making another video about these guys. I'm gonna dip them underwater. And we're even gonna do that in this video. We're gonna have a little glimpse of those guys taking a dip. So here's La Perouse Bay, McKenna Hill on Maui, looking towards Molokini in vain. Why should we waste our time right now? Because we know we already sent it past the curvature of our Earth. Our curving Earth, does it make us on a ball? I have a bunch of curves on my body. You think I look like a ball? Does that make me a ball if my elbow is rounded? If I look at the tip of my elbow, it looks very round. Does it mean I'm a ball? And when I look at my balls, they don't even look that round. They look more like eggs. Anyway, this video is not about my balls. Alright, now we're getting lower at 429 feet of elevation. You can see it's kind of very arid. It's dry, lots of kiawe trees. Even the kiawe trees look kind of dead. So let's look over. We got Kaolave in front. And set this up there. We have a hard time seeing Lanai, but it's here. Whoa! Right. Here's Lanai. And too bad there's too many trees there. But what I want to get to this point here is, you see the height between the two islands, the height between the top of the island and the ocean, and there, okay, they're getting almost to the same height. Some feature we can be observing at this point. And the just to give you a little idea. Lanai is what? 3,366 feet. Looks like there's a Freemason somewhere that decided that. So that's the height of Lanai, the island of Lanai. And the island of Kaho'olawe is less than half of that. It's below 1,500 feet. And they almost looks like they're at the same height from this point. So here I'm at 360 feet of elevation, getting closer to Mahukona, Rapakahi. You can see the telephone posts along the highway, and I'm right above it. And you can see a bit of the grounds around Mahukona, boat out in the water. Here's some of the buildings we could see in the beginning of my video. And out that way is Hualalai, that's the big mountain above Kona. Kona Airport is down here on the right side. I have a video about the little pu'u next to the Kona Airport, measuring the elevation of what we can eclipse. Here's the top of, that's Mauna Loa, the biggest mountain on Earth, the most voluminous mountain on Earth. Here's the top of the Kohala Mountains, and the top of Maui back there, and we could kind of see some snow on the top. Kind of see it between the trees, see a bit of snow up there. Mauna Kea, the white mountain, doesn't have snow year-round, but sometimes I've seen snow up there in June some years, a few different years. Anyway, looking towards the other islands, Maui obviously on the right. You can see our windmills. We'll look at them a little later. It looks like we don't see McKenna Hill anymore down by the shore of Maui. It's Lanai and Kaho'olawe. Am I making any point right now? Not so much. Panning out, back out. Okay, look at the height. You can have a hard time seeing the top of Lanai because of the clouds, but they almost look like they're the same height. Okay, as I'm going down the hill. 288, still going down the slope, getting closer to the water level. Still above the highway, still above the telephone posts. People still use posts for a telephone now? Power line, should I say? You see the height between Lanai and Kaho'olawe, almost look the same. Do they? Almost look like twins at this point. Not even trying to find Molokini anymore down at that level. You won't see it unless we climb up the hill again. But no, I'm just gonna call my wife and have her pick me up. So no more McKenna visible on the shoreline of Maui. Okay, next one. 193. I have a bit of landscape in front of my camera level, taking out some details. Alright, we're still looking at the same things. Don't want to waste too much of your time. Let's skip along because there's some details closer to the bottom that might be interesting. Now it's really dry on the ground, a lot of dead trees. See the waves splashing on the shore, on the point here. The Mahukona warehouse. Looking towards Maui. See more details down at that level. Because of the air, there's less clouds at that level. But we are missing the bottom of the islands. We cannot see that due to the curvature. Oh, I'll show you the windmills. Are we going to see them? We'll see them better later on. So we don't want to waste too much time. Okay, I'm standing right next to the lighthouse. And my altimeter says 65 feet of elevation. Okay, let's pause it right there. Let's go to the elevation finder. Okay, this out a bit. Full screen. Napakahi. Okay, let's go take a close look on the grounds there. See the little lighthouse right here. Try to get closer. You see its little shadow right here. I'm standing right next to that monument. Or not a monument, but a landmark. Let's take a look at the elevation. 43 feet. Okay, here is 46 feet. Here's 43. 43. Okay, so we're pretty much there. 39. 46 feet. Okay, we got it. Back to my video. My altimeter says 65. So I'm about 20 some feet mistaking here, according to my altimeter. Not too bad, coming down a slope that was over 1,500 feet of elevation. And remember how it jumped one time, about 100 feet. Here's Mauna Kea. You can see all the observatories wasting money. And they even want to stick a new one, the TNT, against the will of the natives, the Hawaiian natives, or a lot of logical people don't want that. You don't need another observatory, believe me. And they want to stick it into sacred grounds the Hawaiians been holding forever. Alright, so it's not really what I want to show you here. Here's a pu'u. I have another video, the pu'u ku'ili by the airport, the Ellison Onizuka. The astronaut that, did he die or not? They named an airport after him. One of the people who were in the Challenger when it exploded in 1986 and still have an impressive job nowadays, still alive with his buddies. Ellison Onizuka. Is he a Honisaka? We'll see. Anyway, we're looking at Maui here. And we're gonna be seeing, what do we got? Where are they? The windmills, where are they? Thanks again for your patience. Is it worth spending so much time trying to figure out what shape is our world? Try to ask anybody what shape the world is. See what they have to say about it. If you try to argue them, you better have your arguments ready. Here they are, the windmills. No more McKenna, totally hidden by the curvature. And look at our windmills. Here we go. One, 2, 3, 4, 5, 6, 7, 8. See the bottom one starting to dip into the ocean here, thanks to the curvature. All right, we got it. Next one. Now I'm as close to the water as I want to get. My altimeter says 26 feet, but my camera eye, I would say, is about 6 feet over the water level. I don't want to get any splashing of salt water hitting my Nikon P900. So I'm being careful. So I'm 6 feet over the water level. Do we see much? Can we even see our two other islands, Lanai and Kaolave? Can we see them down at this level? Let's look for them. With patience, please. Don't see much. Don't see much. Let's see. Whoop! I see a little island top sticking up here. Do you see that? It's a little hard to see, but if I move it, you'll see better. You see? Island top here, which I believe is Lanai. You see it? Island top. Whoop! Moving away towards Lanai, Kaolave, I mean. Whoa. Sorry. Lost balance. Fell in the water. Gladly I stayed dry. Let's find those two islands again. Oh, I saw Kaolave on the right, but I'm panning left just to make sure I'm not missing anything. Coming back towards the right, zooming in. Where are you? Okay, starting to see Kaolave. See the low grounds here? You see it? Low Kaolave. Okay? And then it seems like there's a big gap because from the top of the mountain, they look like they're touching one another. Kaulave and Lanai. And where is Lanai? I can't see it very well here. Kaulave again. See Kaulave. And where's Lanai? You see. Very hard to see. Here's Kaulave again. Searching for it. But remember, we saw it. We're still searching, but we saw it in the beginning of this clip. You can go back to it if you want, or you can do that on your own. Don't want to waste too much people's time. But remember, if we can see it, if we saw it, you still see it? Oh, there it is. There it is. I gotta back up a tiny bit. Okay, you see it right here. So we can see that island top. And going towards Maui. There's the beginning of Maui. Makena Hill totally gone. Okay, so we see the mountain top of Lanai, which is 3,360 feet tall, if you remember. And how far away is Lanai from our observation point? Take a measurement. Lanai summit. About 78 miles. Okay, 78 miles. What does that do on the calculator? 78 miles squared. 6,088. Okay, we multiply that by 0.665. A little bit less than 2/3. So we shouldn't be able to see anything below 4,045 feet. And my camera eye is about 6 feet over the water level. And I can see the summit, which stands at 3,366 feet. There's a chunk missing here again. All right, last shot. Just wanted to show you the windmills. Still at the same place. Still being careful with those waves. Right, look at our windmills right here. Okay, let's start counting. 1, 2, 3, 4, 5, 6, 7. Uh-oh, 7. There's one missing. Is that one here? 1, 2, 3, 4, 5, 6, 7. And this one's dipping in the water. But I'll show you a whole video about that. The windmills taking a dip. And I'll show you the measurements of that. So thank you for watching. Bear in mind that the experts shouldn't be equal to God. Or gods. The Elohim. Okay, thank you for watching. Please keep your eyes open, keep your ears open, and all of your senses. Don't intoxicate them, please. Keep them healthy, because you really need that now in this day of age. So until next time, aloha.